Okay. Good morning, ladies and gentlemen. Welcome to the second Cortex Logic workshop. Yesterday was actually very interesting. It was it full 3 hours? Yeah, it was a really great session. You're going to do more or less the same, so I'm really looking forward to that. Yeah, so just very quickly to introduce Jandre, the little story that I normally do. That I did yesterday. So Jandre specifically, he's going to he's going to run this workshop. I'm just going to do a quick introduction to Cortex Logic and some of the use cases, and it's almost like a little flash talk that I did yesterday as well, just talking about what we're about, just to so you can get an idea of what we're doing. But the main focus of this workshop will be to actually go through very specific vision applications using deep learning, and he's actually going to take you from scratch through it. And we're looking at things like there's going to be binary classification, there's going to be object detection. He's going to look at specifically at traffic, which is going to be interesting. What's a truck, what's a vehicle, and those type of things. So we've got access to live stream data. So that's going to be cool. And then segmentation as well. When you look at a human figure, to segment that out as well. So it's going to be practical. Are you going to cover all of that today as well?
I'll show examples of that, but the use case we're gonna cover today is a multi-class classification problem.
Awesome.
So that we're going to do in detail, and then I'll show you, because the other tasks are very similar, has a very similar workflow, and I trained a few models, and I'll show you how it runs on the web, using the webcam.
Awesome. So it's going to be nice and practical. Now a little story here. So there's deep learning in Daba going on in Stellenbosch. Who knows about deep learning in Daba? Okay. Why are you not there? I was there. We actually launched it. No, this is great. This is going to be. I'm glad you're here. You're going to learn a lot. You're going to get something similar, even better, right here, because it's going to be very specific, and we're going to unpack some specific use cases. But anyway, just a quick story. So last year we had a deep learning in Daba at Wits University. There were over 300 deep learning practitioners, or people that just participate in the conference. I think this year is 500 plus at Stellenbosch University. But anyway, right, and I was there, and we had a bunch of people there, and Jandre was also there, and then right after that we had a hackathon, a vision hackathon, focusing on potholes. You know, potholes are the big problem here in South Africa.
We didn't know each other.
What's that?
We didn't know each other at the end of.
Yeah, we didn't know each other at all. So he was anyway. So, but he obviously applied, and there was a bunch of other teams. There were some big teams. There were some companies. Authenticate, for instance, they just specialize in this as well. And they had their laptops and their teams there, and everybody was organized in teams. If you go to the Machine Intelligence Africa.org, who knows about MIA? Machine Intelligence of Africa, okay, a few. I would recommend that you all just, it's a non-profit organization, it's an AI community for Africa. It's looking at, I can show a bit more details about that as well. We're hosting a bunch of events. We have that one hackathon that I will talk a little bit more about now. And we're also looking at projects and all sorts of different things. It's a non-profit organization really building, it's machine intelligence and data science research and applications. And the focus is really to transform Africa using smart technology. So it's worthwhile going there. Anyway, if you go there, you will see there's a bunch of resources listed there. Courses, training, tools, all sorts of things. And also our events is listed there. And on the events section, you also see the hackathon. With the details, the problem. I think we've got links to the winning Python notebooks, the solution to data and everything. It's actually there. So it's worthwhile looking at that. But anyway, you'll see the photos and everything there, so you get a sense of that event. But it was an awesome event, it's a full day event. And the bottom line is, he was the winner. He won the competition. So as a one single guy working in that So but it's worthwhile looking at the presentation and sharing that. But anyway, so obviously we've appointed him in Cortex Logic. So we're looking at top talent and stuff, so there we go. Anyway, so just a little story there, and it's also relevant in terms of what Cortex is doing. So we're just focusing on the vision applications. There's a bunch of stuff in terms of that. If you think about unstructured data, video, audio, text, and so forth. You see, vision is a very important thing. Another area of expertise, or important area for us, is natural language understanding. And we're building customer service chatbots, and we've got Telkom represented here as well. So really, that's awesome. But it's important for us in terms of robo-advisors, in terms of in healthcare industry. If you think about companion or chatbots that actually help you with treatment plans, we're busy building those type of solutions. It's a very exciting space. And it's also, if you think about phones with intelligent capability, it actually provides you with the opportunity to get more information about the user. So it's like a sensor on you. And that information is important to actually feed back so you can have more context about a user. Anyway, so what I'm going to do very quickly, brief introduction, then I'm going to give it all over to Jandre. And I just want to say thank you to Peter Wilson as well. So he's been helping us big time on all sorts of levels. So, but there will be some exciting stuff that he will present as well. He's a GIS data science expert, so we'll talk more about that. Anyway, so Cortex Logic. So what do we do? So we're an AI engine for business, for platform businesses and corporates. Now we live in the smart technology era. So you see all these disruptors. You see Airbnb, Uber, you see Google, Facebook, all these companies are making incredible impact on all the biggest companies in the world. And it's all platform businesses, data-driven, AI-driven platform businesses. If you look at Amazon, recently got to $1 trillion, and Apple is also $1 trillion company. Now, what we are doing is we recognize a lot of opportunities in niche areas, in certain domains, in certain industries where there's platform or there's businesses that needs to be data-driven, AI-driven, and what we do is we operationalize AI. So we provide end-to-end AI solutions. We're also helping corporates. They need to thrive in this new smart technology era. So that's something else that we do. So that's kind of a summary. So if you think about any solution, because it's so data-driven, if you think about the AI machine learning toolboxes being enriched by the deep learning stacks and all of that, the ability to work with unstructured data as well, not only structured data, it's very important to enable smart data as well. So that is an important foundation. And then effectively what you want to do is you want to automate your AI effectively. And you can't automate if you don't have rapid access to all available data. So this is all part of that end-to-end pipeline. And then what you also want to do, so what do you do this for? You want to integrate this into the business, into the workflows, into the intelligent virtual assistants, into the omni-channel as well. So those type of things is very important. You want to help with decision making. So that's all critical pieces. Anyway, so you can see end-to-end solutions captured there. And you can also look at solutions from this perspective where you classify helping to optimize the business. For all customer-facing businesses, you want to actually have a growing, satisfied customer base. So that is critical. And then you've got employees, which is very important. There's a saying that technology makes it possible, but people make it happen. And so productive employees is absolutely critical. And then smart systems, cybersecurity, fraud, all sorts of things, which is important. And really, what do we do the AI? It's nice and cool to work with AI and build these applications, but it needs to serve a purpose. It needs to solve a problem. And if you look at business, it's really all about the value drivers of the business. And you can, I've just categorized it here, you can look at increasing operational efficiency and effectiveness and revenue. So you want to up the productivity, increasing automation, improving processes, but also if you increase the revenue, even things like cross-selling, upselling, recommendation engine, as you know, is very important. But I think also critical, if you think about the mining industry, minerals, metals, manufacturing industry, 1% improvement in throughput, yield, quality, implies millions of dollars. So there's a lot of value in that. And then also for those type of companies, reducing the risk is also important. So predictive maintenance. If you think about a jet engine, you've got say 3,000 sensors around that. With that information, you can in real time build a predictive model around the state of that jet engine. That information is valuable for predictive maintenance purposes. So you get companies like General Electric that's actually selling not only the jet engine, but also the SLAs that goes with this. So this is very important for those type of companies. And in healthcare, if you look at MRI scanners, and it's all about availability and making sure that this thing is actually in production, can work. And there's many, many other use cases. And obviously we know that you can create strategic value with AI. So data's the new oil. If you've got access to data, you can create more revenue streams. So that's very important. And I think for customer-facing businesses, that's the third category there. It's really, I think we've got now a wonderful opportunity to create truly enhanced customer experiences and have more targeted sales and marketing. Now, and this is all what we want. If you look at your cell phone, I think we started getting used to real-time, on-demand, digital, personalized services. And if other businesses are not providing that type of service, you feel it's below par. What's going on here? We expect more. So that is driving a lot of businesses to actually embrace this. Now, if you think about AI, I think there is obviously applications in data science. In actually, I talk about deep 360-degree insights about the customer, unlocking the value there. We've got a rich toolbox there. But on the human-computer interface, the technology is becoming mature enough to actually help with natural language understanding and all of those type of things, so you can actually have a better human-computer interface, communications and stuff. So that's a different application area of AI. Anyway, so that in a nutshell, I'm going to skip a few things here. You can go to the website to get more information. This is just showing more the bigger story in terms of data lakes and data warehouses and how do you actually enable that. So I'll skip that for now. And maybe this, and then I'll show you one quick example, and then we can start straight away with this. It's already a bit longer than 15 minutes. So if you look at your analytics spectrum, you get different types of analytics, and we can apply different types of AI. So there's descriptive analytics, what happened, diagnostic, why did it happen, discoveries, what's hidden in the data, as you use unsupervised techniques to look at the natural clusters in the data as well. Predictive, where there's a lot more value now, because you can actually now predict and forecast going forward. You can predict current values, but you can also predict into the future. And to predict into the future is just a data preparation exercise, because you basically still create input-output mapping. If you look at a neural network, it's an input-output mapping, but if you shift things in time, you say, I'm not just learning current state to current output, or current input to current output, I'm actually having looking at my current inputs maybe, and also past inputs, and I'm mapping that to future, maybe a day ahead, a week ahead. Then you learn that input-output mapping. As well. So there's so many things that you can do in arranging your problem and constructing that. So predictive is very important, but I think what's absolutely critical is the prescriptive side. So what do you do with this information? Can you actually give people advice? Can you help decision making? Can you give a prescribed action? And this is where things are going as well. And you will see also AI, you will also see decision making being automated. So I've got another slide that talks about assisted intelligence, augmented intelligence, and then autonomous intelligence. So you see this in investing as well, where there's a decision automatically being made. And obviously one needs to be super careful with that. But if you think about even things like advanced process control, when you actually close the loop in a plant setup, you can actually clearly see where you're actually giving very specific actions to the operator. Maybe this is what you need to do to tune the process, or you actually close the loop and you just update the process accordingly. It's a non-linear dynamical system, and you just update that. So those are all examples of prescriptive. And then finally, cognitive is where it's really more natural communications, where the enhanced computer interface comes into play. But it's also about explainability. If you make predictions, you make prescriptions, you would like the AI to actually provide you with information around the very specific actions that have been taken. Why has it been taken? So that is pretty important. So you want to reason with purpose. You want to learn at scale. We're also talking about real-time learning. Okay, so so maybe the one simple example I just want to quickly show you, because this is kind of topical, and I shared this yesterday. So this is an example that's generic across multiple customer-facing businesses. Churn. People are really worried they lose their customer base. And so I just want to quickly share this very quickly. So this is an example where we're looking at funeral policy insurance data sets. So this was main members and dependents, and there's payment transactions. And in this particular instance, we built predictive models that's pretty accurate, 94% accurate on test data. So that's critical as well. You don't want to have accurate models that's just on the training data. You want to make sure that it can generalize well. So it's very important that it's not memorizing. You test it on unseen data that's not been through the training. And this is an example of that. We've built models here not only for lapse propensity, but also for non-active members as well. And this is the kind of analysis that you typically do before you actually build the models. You can look at the factors. You can look at the gender distribution. You look at the planned region distribution. You maybe want to remove outliers to help your models. You're looking at the member age. You can see it ranges over the whole spectrum there, all the way from, say, 20 to 90 or 90 plus. You look at all the branches. This is now funeral policy insurance data, so Port Elizabeth, Mitchell Plain, Worcester, all these places. Premium, you can look at exactly the premium information that's available. What are the people paying? The expected payment method, CPS, debit orders, telecash, all those type of things. You look at, is the plan active, not active, lapse information. And then you can look at the brands, all the various brands, what the distribution looked like, the plan types, and so forth. And then you build your model. And in this case, I've mentioned 94% accuracy on the test data, very good model for lapse propensity. But once you've got a model, you've got something powerful, because you can actually now look at the variable importance, and you can very specifically see which of these variables are key variables in terms of lapse propensity. And here you can see plan cover, plan use term, and you can look at in this case we actually use random forests, so you can look at the decision trees and so forth for the particular model. And then what's really powerful here, once you've got a model, you can now interrogate the model, and you can do all sorts of interesting analysis, where you can now do things like the average probability to lapse by plan, brand, and plan category. So now you get a ranking. Now this is now really focused on lapse, why people are lapsing. And you can see exactly on the right-hand side, right-hand corner here, you see the plan brand. And you can see the brands that's really, where people are really lapsing. And you can see the ones that's not really a factor. But you also see the plan category. And you can do the same across age, gender, plan active, plan cover. So here we don't have the gender available for everyone, so it's a non-category. But if you look at the males and females that's available here, and you look at the age distribution, you can see the people that's really lapsing here is more the males and between 13 and 37. So this type of information is available. There's a probability associated with that. Males lapse more than females in this instance. But you can look at plan cover as well. But then you can look at the plan branch. You can see the branches where lapses are happening, like Beaufort West, Kroonstad, Port Elizabeth, those specific ones. And you can also look at your premiums, plan premiums, where you can say, all right, 350 and 500 rand a month, there's where the problem potentially is. So now you can maybe do something about this. So this is an example of where you can uncover insights from the models and provide very useful information. And you can actually now take these models, embed this into AI solutions where you operationalize things as well. So this is a really good practical example of this type of thing. You can look at payment methods as well. But anyway, so that's all I wanted to show. There's a bunch of other use cases. We're going to have a very nice, I'm looking forward to Jandre's presentation now. He's going to take you through the vision applications. So without further ado, Jandre, please come in.
Hi everyone, I'm Jandre, and you can call me Jan, it's a bit easier. And I'm a data scientist at Cortex Logic, and I'll take you through the rest of this workshop. So just to, the goal of, we're deviating a bit, we're deviating a bit from the official description of this workshop in the program. Instead of, the initial plan was to show you all of the tools available for doing computer vision with deep learning. And there are actually quite a few, and we later on thought it's going to be quite, it might confuse you if we show you everything and show you how to do a single task in all of those languages, using multiple other tools also necessary for getting the job done. So instead of doing that, we decided we want to narrow it down to a single set of tools, so that we can actually get our hands dirty and code up a project from scratch for a computer vision application. And today I'm also going to do something a little bit different than what we did yesterday. I prepared a few notebooks to solve a few computer vision problems, but I found that I think I lost a few guys during the middle of the session because I was just going through the already written notebooks and scrolling down and interpreting or translating the code to them. So what I think what might be a better way of doing it today is actually coding the whole thing from scratch, from setting up the environment where we're going to run everything to the deployment. I haven't looked at this data set before. I haven't written any code on it before, but I'm going to see if we can build this thing in the duration of this workshop and see if we can actually get it to work by the end of the workshop. So please bear with me if I make a few mistakes or all of the things, because all of the things aren't going to work perfectly from the start, but hopefully my thought process and maybe with some of you guys input, we can learn from each other and you might get a good idea. So I hope you would also get a good idea of what tools there are available and how to use them, and so that you can also learn what is possible with all of the technologies that is available to us now. So just to get a feel for you guys, who of you write code on a regular basis? Okay, quite a few. And who of you code in Python? Okay, a lot. And has any one of you trained a neural network before? Convolutional neural network? Can you raise your hands? Okay, some of you. That's good. So I'm actually gonna, so I'll try to do this on a beginner level, and just to manage some expectations. Also, there aren't going to be any formula on the screen. There's not going to be any proofs or any theory. It's just going to be a practical session, only code and Jupyter notebooks. And the reason for that is I think there's a big gap between people knowing the theory and knowing how to apply it. So, and there are lots of resources on knowing the theory, on learning the theory, and not so much on how to actually implement the solution. So I'll try to, if there are some new machine learning, deep learning concepts that I introduce, I'll try and give a higher level overview of what it is and what it does. But I'm not going to try and explain or prove anything mathematically in this session. So to give some context, and something that I can reference to throughout there's a bit of a lag or delay between my screen and the monitor. I want to show you a scene from a series called Silicon Valley. I don't know if any one of you watched Silicon Valley. So for those of you who don't, it's a bunch of guys in a tech startup, and in this scene, one of the guys developed this app where it's called Seafood, where you can take a picture of some food and it's supposed to tell you what type of food it is. So it's like a Shazam for food. And in this scene, the guy is very excited to show the rest of his team how this app worked. So I want to show you the scene. sure if there's volume. Peter, can you? And just, actually I need to ask this before I show it. Are any of you, okay, so there are some swear words in this. I couldn't find an uncensored, like a censored version. There are a few F words and some derogatory language being used. So would you be okay if I show it to you? If you think you're sensitive to this, you might want to leave the room for minutes. Do you want to ask something? Sorry for this delay. Okay, so I don't know what's wrong with the connection now because it's not following my screen. So you might experience a delay between the sound and the visual as well. That's something about
Wow, Dinesh, this front end design looks great.
Thank you.
This
Nice
worked
work.
perfectly yesterday, but I think there might be a problem with the connection. Okay, so I don't think this is going to work now.
That is a burrito for the test. Good to know.
Let him have it. Gilfoyle thought he was too good to work on seafood, and now he's about to lose a fortune. Okay, ready for test. After you, milady.
Okay, so it's not going to work like this. There is sound, but there's a huge delay between my monitor and this one here. So even if I just move my mouse around, it's very slow to get to that. Do you have a Mac adapter for HDMI Mac?
Yes.
No, that's good enough. Sorry guys, let's try again. That's okay, I can manage the sound of the other side. Okay. Thanks a lot. Yeah, we're still going to have problems. Let's see how far we get. Yeah.
Too good to work on seafood, and now he's about to lose a fortune. Okay, ready for test.
After you, milady.
Oh, this is weird. Mia just texted me good luck with the demo. Did any of you guys tell her about this?
Your hacker girlfriend wouldn't happen to know the model of our router, would she?
Yeah, actually, she complimented your choice.
Why didn't you say anything?
Why would I tell you? She said something nice about you.
Damn it. You have to assume she's everywhere.
Okay, it's ready.
Please, God.
What will you say if I told you There's an app on the Marais. We're past that part. Just demo it. Okay. Let's start with a hot dog. Holy shit! Motherfucker! Huzzah! Jinyang, my beautiful little Asiatic friend, I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves. You'll never feel exposed again. I'm gonna be rich. Fuck you, Guilfoyle. Do pizza. Let's do pizza.
Yeah.
Hey, Zach.
Not hot dog? That's it? It only does hot dogs?
No, and a not hot dog.
Slow again.
Fuck. I gave you the ability to spin gold. Instead, you spun pubic hair with shit in it and gravel and corn.
Hold on. Jinyang actually put together a pretty good classifier. You know, I mean, the Cortex is valid. It just needs to be trained.
So what he did for hot dogs, he needs to repeat for every food in existence.
No, that's a very boring work. It's a scraping the internet for thousands of food pictures. You can hire someone else.
We can't, because we just spent a big fat stack of cash on little Dinesh over here. And there are other expenses. Legal, marketing, operating fees, those goddamn AWS charges. Fuck us. And so, we do not have the funds to hire scut workers to do your scraping for you. And thus, you will scrape the internet. You and you alone.
I'm sorry, the time to back out was before you signed the term sheet. I'm gonna tell Lori that this was a smashing success. Go make it one.
Yep.
Okay, so yeah, sorry that didn't work out as planned, and we're still waiting for an adapter so I can plug in HDMI in here. Otherwise, this delay is actually going to make it difficult for you to follow. But so the reason I want to show this to you is that they actually make a few good points and some relevant points when starting a computer vision problem. Is so they're mentioning AWS charges in there, and they're talking about a lot of data that they need. So obviously his seafood app is not working as everyone expected. It can just do hot dog, not hot dog, and now they want to make it work for more food categories. And we said now they need to scrape a lot of images from the internet just to get this model to work for those images, for those food categories. And so there is this myth in deep learning. I call it a myth, but there is some truth in it also. But that you need a lot of data and that you need a lot of computing power to do anything in computer vision with deep learning. And to some extent that's true, but there are also a few workarounds that we can use to make it more accessible for people like you and me. And so yes, you need big computers, but you don't have to build one yourself. All you need is access to a graphics card, and that you can get on AWS. But AWS, which is Amazon's cloud service, their renting and computing time is quite expensive, like they say in the scene. But there are some alternatives, more that are a lot cheaper than AWS. And the one we're going to use today is called Salamander Ai, and it's a fairly new service. And I think the cost of running something on there is I think at least a quarter of what you would pay when you do it on AWS. Did you get one?
No, there was a good email. I just wanted to see if you changed your markup connection. It's meant to be one for AV, non-internet.
That's where I'm on now.
Oh, you are. Else. Try number 11. It's blocked. Okay, the opposite.
Okay. But it's going to be difficult.
Yeah,
so I think that Yeah, and the thing about the data is that if you want to train a convolutional neural network from scratch, you'll need anyone. Sorry to ask you this, but does anyone have a Mac adapter for HDMI cable?
Is it a USB-C?
No,
Thunderbolt.
it's either Thunderbolt and we always.
Yeah, Thunderbolt.
I've only gone for USB-C.
Okay, thanks. The thing about the data is, so if you want to train a convolutional neural network from scratch on an image, on a computer vision problem, you will need a lot of data. But the fact is, you actually don't need to train it from scratch. People have already done that hard work for you. So there's this big data set called, and most of you have probably heard of it, called ImageNet. And there are, I think, 8 million images or so in there with 1,000 classes, labeled with 1,000 classes. And what people do is they train a convolutional neural network on that data, and the things that model learns on that data are actually the features that it's able to extract from that data is actually transferable to other related computer vision tasks. So then all you have to do is you get that model that people post online or share the parameters online, download it into your environment, and you plug that into your model, and then you fine tune those parameters just to fit your data. But by doing it that way, you don't need you only need a few hundreds of data or images to train your model with. So that's exactly what we're going to do today, and I'll discuss it in a bit more detail soon. But so what I want to show you today is actually how to build a seafood app like that in this show. And I'm going to do it entirely from scratch. I actually saw yesterday, okay, no, let me just start doing this. So I said we're going to use, and is there anyone who wants to follow the code by themselves now? Would you be interested in doing it like that? Okay. So let's see if we can, if I can accommodate you and that it doesn't take too much of the other people's time to follow me. So if you want to try and copy what I do, you're more than welcome, and you can also stop me if there's any questions you have on what I'm doing. So I'm first going to go to the Salamander Ai Dashboard. And obviously to get started, you need to create an account, and I already have an account. And sorry, just for those who are not doing this themselves now, I'll put everything online, and I'll share the link. I'll get your emails from the organizers and share it with you, so you can then just run it on your own time. So I'm going to log in. Okay, so this is the main page where I can create a server now, and with this server I can choose. Okay, so here's the name and the location, and you can actually, they have like this witty name generator that you can use to name the server. So I'm going to go with that one. I'm going to choose the amount of storage that I need. And here I can tick. So also compared to other cloud service providers, this one is a lot easier to set up, and that's a huge bonus. And I also need to add that I spoke to the guy who created this, and I asked for some free credits so that you guys can try it out. And so he didn't give me coupons just for us, but he said for yesterday and today, we'll make if you sign up for yesterday or today, you'll get $3 of compute time just to try it out. So that's very generous of you. So yeah, I just choose the libraries that we are gonna that you can get pre-installed on the server. And so what we're using today is a library called Fast AI. Has anyone of you heard of the Fast AI courses or Jeremy Marwick? None of, yeah, okay. So Fast AI is firstly it's a set of courses online on, it's called Deep Learning for Coders, and I can highly recommend anyone who wants to get started with deep learning to have a look at those courses. There are 14 courses of around 2 hours each, and it's an amazing set of material, and there's a huge community, active community. They have this forums page where everyone talks about it and help each other and share their project. And alongside this course, they built, and everything is free, and they built this library, this deep learning library also called Fast AI, and it's built on top of PyTorch. And so with this library, you have the flexibility of using of doing deep learning. They wrote a lot of wrapper functions, helper functions, so that you don't have to do all the coding yourself, which makes it very easy to code up a deep learning model. But also it allows you to go a bit deeper into the code and be very, like, scratch around in the lower level code if you really need to customize those parts of the model. And they're actively working on it, so every time there's a new paper coming out, someone in the community would implement it and add it on to the Fast AI library. So when there's so it's like state of the art things you can play with using this library. The other option is obviously, you have a question?
Yeah, I'm wondering, how does that compare to something like Keras? Is it even more?
Keras, it's very similar to Keras.
Okay.
Yeah. So Keras is built on top of TensorFlow, right? And I think with Keras alone, you don't have that flexibility of actually, you only have that higher level. Last time I worked with Keras, you only had this higher level functions that you can use, and you can't actually code up the lower level operations. You can add a layer and you can train the model, but you can't actually go define a specific custom layer, for example, or a custom node function. That you need TensorFlow for. But I think they're improving on that, and I think the library you choose to use is between TensorFlow and PyTorch actually doesn't really matter that much. I just prefer this Fast AI library because of the community around it and the it's backed by an open source non-profit organization, and I just like to support them. And yeah. So, but if you like TensorFlow, by all means, do using TensorFlow and Keras. So we won't need TensorFlow today, and so I'm just going to uncheck that box. And here you can choose the hardware you want for your server. And I'm going to go with this accelerated computing version 2. You see it's $1 an hour, $1.20 an hour. But for most cases, and for just experimenting, this K80 GPU would be enough. I just want to want the things to run a bit quicker in this session, so we don't waste time waiting to train. So this is a 16 gigabyte graphics card, and it's very nice to work with. So I just need one of them, and I'm going to launch the server. So it's going to take a few minutes just to get everything started. I would like one of those, please. Can I get it? There's still a bit of a delay. Do we need to sit down now? Yep. I change this aspect ratio now. Sorry guys, so I have to sit to the side now, and I hope you can all still hear me and see me clearly enough. So let's continue. Hopefully, yeah, so my server called Alt Conductor is running at the moment. So all the code I'm going to be running today is in the Jupyter Lab environment. And they made it very easy with this website. All I have to do is click on this link and it's going to take me to the Jupyter Lab running on this server. So I don't need to SSH or open a terminal or anything to get access to this machine. And also I just want to say that the first time using a machine like this for the first time is a bit slow, but once you've run everything for the first time, then afterwards it runs a lot quicker. So it's just the initialization phase takes some time. And if the internet connection is not great, then so let me just explain, let me carry on while I wait for this to load. So if you want to build a computer vision application and you want to use deep learning to solve a problem, there are 4 things that you'll need to successfully build the application. One is you'll need data, and you'll need labeled data, meaning, so if the task is the seafood app, you'll need a lot of pictures of different types of food, and you need to know what type each of the images are. And you'll need a model, and the model is what we're using as a convolutional neural network. But today we're going to treat this as a black box. We're not going to go into the details of what the convolutional neural network is, but all you can think, you can try and picture. What I want to say about a neural network is that it's a set of layers, and at each layer there's some operation happening, and at each layer it takes an input, do something with that input, send it to the next layer, to the next, until you reach a final output. And in this case, our output is going to be the score for every food category that we have in our data set. And then when we want to classify an image, we'll send this image through this model and get the scores for each of the categories, and the category with the highest score is the one we'll label our image with. But you'll see how it works in just a second. The other 2 things you'll need is a loss function, so determining how well a model is doing, so comparing the model predictions with the actual values. And the last thing we'll need is an optimizing function or optimizing procedure. So how we're going to, it's just the way we're going to train, is the way we're going to optimize the weights in the convolutional neural network to get the best outputs from it. But we're not going to discuss that today, and Fast AI makes it very, for Fast AI, all you actually need is the data and the model. It takes care of the loss function and the optimizing procedure for you when you're coding. So it actually picks up from your data and the model that you want to use which loss function would be the best and which optimizing function would be the best for your use case. So which makes it very good for beginners, but also you have that ability to change the loss function or to change the optimizing function if you think you know better. So the data, so depending on the use case, there might be data sets already for what you want to do. So that means you don't have to go and collect images yourself and label them yourself. There are tools available for that, but ideally you would want to avoid that process because it's quite time consuming. Especially if the task is like a segmentation task or a detection task where you actually have to go and draw polygons around the things you want to detect, or you want to draw bounding boxes around the things you want to detect. So the first step in any computer vision application is to see if there is not data online available already. And the best place to go and look for, well, I can't say it's the best place, but I think it's a very new tool from Google called Dataset Search, and we discovered it a week ago only, and I haven't used it a lot. But I'm going to it now. And so if we want to build the seafood app, I want to look for food pictures or a data set with lots of food pictures in it, and I want to know what type of food each of the images are. So I'm going to search on this website for food pictures. So here is a list of data sets that correspond to my search. And the first item is this food images, food 101, posted on the Kaggle website. And when I read the description, it looks exactly what we need for our use case. It has 101 food categories and it has 1,000 images for each of those categories. And yeah, so like I haven't done anything on this data set before. I actually saw it yesterday for the first time when I demonstrated this search tool at the workshop. And when I looked at it again, I realized it's actually exactly what we need for doing this. So I'm going to download it. But so I'm going to go to the Kaggle website. Kaggle is slow today. So to get this data on our server, we'll need to use the terminal. So in Jupyter Lab, we have this option of opening a terminal running on this server. And so we can't click on the link and then it will download this. So we actually need to write a command in the terminal to get it. So we use the wget command, and then we'll need the link to that data. But on Kaggle, you'll need, you actually need a profile if you want to download the data set. But there's this useful tool called curl wget on Chrome, so you can search for curl wget. And it's this extension that you can use that will give you the file path to something that you want to download. So I already added this to Chrome, and then say I want to download this data set now. I can click on this download link, and the download is going to start, but this is obviously going to download to my personal computer now, and I want it on my server. So I'm going to cancel this. But what this add-on then does is I can, this curl wget add-on, I can click on it, and it gives me the path to that data set that I just tried to download. So then I can copy this part and I can run this in my terminal over here. And then it will actually download that data set to my server. And hopefully the internet connection there is a lot faster than it is here. First to download. projects that I do, I like to. So I always have a directory called works. No, I'm not. Okay. Let's just make a directory called workshop. And inside the workshop, so I'm going to go inside the workshop directory now, and I'm going to make a directory called data. Let's go back to where I downloaded the data. See if I list all. So there's the data I just downloaded, and you see it's a zip folder, a zip file. So I want to unzip it. And I think, yeah, so I first need to install the zip program, which is, they give you the command here how to install it. Shouldn't take long, because now I have zip installed, and I can unzip this dataset as well. Another thing I'm just going to do alongside this is I'm going to open another terminal on the server, and just the Fast AI library that's on here, that's already pre-installed, is a bit, you see it over there. It's a bit outdated, so I'm just going to go into this library, and it's actually a GitHub repo. So all I can do is just pull the latest code from that library. So our data, while that's going on, you see our data is finished unpacking, and now we can look at the files that we unpacked, and you see there's a images.zip file in there, and that's where our actual images are stored. These are just metadata, I think. So we're going to also need to unzip the images. I'm going to use this command just so that it doesn't display all of the files it's unpacking, and I want it to unzip to my data images directory. First need to make that directory. That's where it's in the workshop. It's actually unzipping that file. That's a file with all of the images, and it's storing it in the data directory that I want it to be stored in. And I think we pulled all the latest code from the deep learning from the Fast AI library, and we just have to update the Conda environment. So if we go into our workshop directory and in the data directory, we'll see there's a folder called images, and inside images there is a directory with all of the types of food, and in each of these, like say in this frozen yogurt directory, there will be a list of images of frozen yogurt. So that's actually the exact file structures that we need when we're working with Fast AI. So let's start writing the program. So I'm going to start immediately I'm going to rename it to, let's call it seafood. And okay, so the main thing, the main libraries we'll need. So we, sorry, I first need to just copy. Sorry, I'm going to copy this Fast AI library to our workspace. In this file system, there's the Fast AI library, and in the Fast AI library, there's a module called imports, from which we can just import everything, and then that's from here. That will then import all of the libraries we need for most of the things we're going to do in here. And as I said the first time we run all of these commands on the server, it's going to take a while, but the next time we do it like this, it's going to take a lot quicker. And the other module we'll need is called Convolutional, and there we'll also import everything. So the main thing. Okay, so what we want in the end is a thing called a learner. So this is just a class according to Fast AI, and this is the main class and the main thing we're going to interact with. This learner class has everything we need to train a model. It has access to the data and how to import the data and how to transform the data. Before sending it to the model, it knows the model. You have to give it the model architecture, and then it also determines automatically. I'm not sure why that is. It also determines automatically what the loss function is and what the optimizing procedure is. And this learner we're gonna define using this conv learner class, and it's called using this pre-trained function, which is the transfer learning part I talked to you about earlier, where we're using a model that's already trained on another data set, but the features that was learned on that data set is useful for any other computer vision task, for most other computer vision tasks. So we need to give it the model architecture. You can look at the arguments of this function. We need f, which is the model architecture, and we need data. Those are the two main things you need to send to this argument to actually create this learner class. So I'm going to show you how to get those things, and I'm going to put this data. So we need an f, which I'm actually going to call base model, and we need a data, which I'm going to call data. But so these things aren't defined yet, and I'm going to show you now how we're going to define it. So inside this notebook, I like to have a path variable just telling my environment where all my data is and where it should store new data. And I'm using this new pathlib library from Python, and I'm just saying data. And so I can, inside Jupyter Notebooks, you have these magic commands, and so this is actually just a terminal command that I can run inside one of these cells. So list all the things in this class for me, see there's our images folders. What you can also do is make an iterator using this part. So we can go path, images, and then list all of the things in this iterator produced by this iterator. And then you see there are the folders for each of those crude categories. And so let's see what an image looks like. Let's say what a hot dog image looks like. So we can go to path, images, hot dog. I think it's actually called hot dog. If I read correctly. So there's this function that we already imported called open image. Let's just check if the file's stored correctly. No, that's not right, sorry. I just need to test these quickly. So let's see. Yeah, so there's one of the files with an hot dog, one of the images with a hot dog in it. And if you actually want to import this image and see what it looks like in this notebook, we can go open image and use the matplotlib library to plot it. So there's an example of an hot dog image in our data set. And we can look at others as well. So I don't know what the other categories are. So you get the idea how we can get access to the data from in this notebook. So what we actually need to do is create a dataset class which tells the model where is this data, how to import this data, what transforms we need to do on this data, pre-processing we need to do on this image before we send it to our model, and also those are the things we need to tell it. But one other thing we need to do before we can do that is split this data set into a training and a validation set. And are most of you comfortable with the difference between a training set and a test set? So we just need we don't want to evaluate our model on the same model that we train, on the same data we train our model on, because then we won't have a good estimate of how well our model will do on images that it has never seen before. So therefore, we just make an independent set of images that our model could not see during training. So to do that, I'm just gonna first, I want to rename the images folder. I want to rename the images folder to, which I'm going to call train. And I'm going to make a directory for valid. So now if we look at our data directory, it looks like this. The train and the validation folder. And so inside this training folder is all of the images at the moment, but we want to take a random subset of that images and pass it put it into this validation directory. So first we need to create directory for all of the classes, for each of the classes in the training set we want to create in the validation set. So for that, I'm going to go for category in so if I do it like this, it's just a for loop with the cat being